Thank you for joining this lesson. We're going to draw graphs of quadratic functions. In number 20, part 1, we are told to draw the graph of the function y equals to 2x squared minus 3x minus 5 for x ranging between -2 and +3. We have the grid provided here. Remember, we are given 5 marks. So what we do, you should know that the first 2 marks goes to the table of values, whereby we need some values of x, then corresponding values of y. So now we begin from a -2 as instructed. There is -1, 0, then 1, 2, and 3. So these are the coordinates that we're going to plot. We start substituting now in the equation so that we may get the value of y. So 2x squared, x is -2 squared, then minus 3 into -2, then minus 5. So the first value becomes a +9. So we're going to have 9 at this point. We substitute now -1. So 2 into -1 squared minus 3 into -1, then minus 5. This gives us exactly 0. Then we go to 0. When we substitute the 0 in this equation, we'll get a -5. The next is we substitute 1. So 2 into 1 squared minus 3 multiplied by 1, then minus 5. This gives us exactly -6. -6. Then we go to 2. So with 2 into 2 squared, then minus 3 into 2, then minus 5. This is going to give us exactly a -3. And finally, we have 3. So we will have 2 into 3 squared, because that is our value of x. Then minus 3 into 3 minus 5. So this is going to give us +4. Those are the values of y and the corresponding values of x. So this is now what we're going to plot. This is what we're going to plot to come up with a graph. So let me work on the Cartesian plane now. So I can have the y-axis at that point. Then now the x-axis. This is the x-axis. Yes. So this is going to be y-axis, x-axis. From 0, we can have 1, 2, 3. Or I can use a larger scale so that I accommodate a good surface or a good portion. So I can use a 1, 2, 3. Yeah, such a scale. Then on this axis, I will have -1, -2. Then now for the vertical axis, because I need a minimum of 9 units on the vertical axis, I can use intervals of 2, 4, 6, 8, 10, then -2, -4. This is a -6, and such. You can also continue up to -7. Then now I plot my points on the scales, -2 against -9. So -2 is here and -9 is here. The intersection will be this point. The next is -1 against 0. So this is the coordinate. Remember, coordinates should be plotted such that even when the graph has gone through them, they are still visible. 0, -5. So 0, -5, -5 is a value at this point. 0, -5. Then 1, -6. So 1, -6 is the coordinate at that point. We have 2, -3. So 2 and -3 will be a coordinate at this point, because this is 2 and -3 is at point here. Therefore, they intersected that point. Finally, we got 3, +4. So 3, +4. 3, +4 is a point located there. So let me now come up with a graph. We come up with a graph by connecting these coordinates. Remember to subscribe to this channel and to also share the link with friends. We want to turn successively. I think there is a point here. It's not adding up well. Okay. Let me redo that. There is the coordinate of 1, whereby it is a -6. It is at a point here. So this becomes our turning point. So we should turn at that point. Then the curve changes the direction. It goes upwards. So this is the curve of the function y equals to 2x² minus 3x minus 5. That is the graph. Already we have it. And the next question is talking of use the graph to solve the equation 2x minus 3x minus 5 equals to 0. So what we do for us to solve any equation is that we take the plotted equation 2x² minus 3x minus 5, and we subtract the equation to be solved from it. So 2x minus 3x minus 5. And when we subtract the corresponding values, y minus 0 becomes y equals to, this one becomes a 0, this one becomes a 0, this one becomes a 0. So y equals to 0. Line y equals to 0 is the x-axis. Therefore, ours is to identify the points where this graph is cutting the x-axis. The first value is at -1, and the next value, which is at this point, is at 2.5. Therefore, I'm going to have two values of x, which is a -1, and the other value of x is +2.5. The next, use the graph to solve the simultaneous equations. So we have this equation, and remember this one has already been plotted. Then this other one. So what we're doing now is to plot the second equation, which has not yet been plotted. We can look for values of x for this line, because this is a straight line. Values of x and y, such that when x is 2, when x is 3, when x is 4, let's work with those few values. So when the value of x is 2, we will substitute 2 here. So -2 by 2, we get negative. We get a negative. Okay, for suitability of the scale which we have plotted, I think it's good we choose values which are going to give us values within the chosen scale, like -2, -3, and -4. Let me see how they'll work. Let me begin with -2. So -2 by -2 will give us +4 minus 2. That will become a +2. Then we'll have -3 such that this becomes -2 into -3. That will be +6 minus 2. We get a 4. Then minus 4 means -2 into -4. That is +8 minus 2. We get a 6. Yes, we get a 6. Therefore, I can start with -2, 2, -2, 2. So -2 is here. This should be plotted against 2. -2, 2. That is the coordinate. The next value can be -3, which gives us 4. -3 will be at a point here. That will give us 4. You can also go to a -1. Let's check what -1 will give us. -1 is going to give us, this will be +2 minus 2, we get a 0. So -1, 0. -1, 0 means a point at this. That is the point. So for this line, allow me use a different ink in the drawing, so I can use this color. So now I pick my ruler and I draw the line. I draw the line now. Yes, so the line is going to pass through this point. The line is going to pass through this point. Yes, so I do a very straight line through that point. So now this is going to be named the line y equals to -2x minus 2. That is now the line which has been plotted. So the next thing we do now is to see where the two graphs are cutting one another, because we have this graph and this one. Where do the two graphs cut one another? For the first point of intersection, we can say when x is -1, y equals to 0. X equals to -1 when y is equals to 0. And again, there is another solution such that the other point of intersection is 1.5, so 1.6 when x equals to 1.6. And remember, this is -1, sorry. This is -1, the first value of x. So the other one is 1.6 because this is the point of intersection. And the value of y at that point is 5. Y equals to -5. Therefore, that is the solution for the two simultaneous equations. And finally, we have to write down the quadratic equation with the line y equals to -2x minus 2. Therefore, for us to get the equation of a line representing a certain quadratic equation, we usually subtract. So for us to get the quadratic equation back, we're going to add this to the first equation. So the equation will be y equals to 2x squared minus 3x plus -2. That becomes -5x. Then minus 5 plus -2, it becomes a -7. So this is the equation which has to be solved.